Hello and welcome back again. This is Prime Time video lecture series part 3. So as we have covered factors and multiples, it's time to delve into the prime numbers. So let's get started. What are prime numbers? Prime numbers are those numbers that have only two factors. First few prime numbers are 3, 2, 3, 5, 7, 11, 13, 17, 19, etc. So the factors of a prime number are 1 and the number itself. So every number has two factors that we know. First one is 1 is a factor of all number and the number itself is also a factor. So these are special numbers which don't have any other factors other than the 1 and the number itself. So guess what is the other set of numbers which have more than two factors called? So they are called the composite numbers. Here are first few composite numbers 4, 6, 8, 9, etc. Now we see that 1 is not a part of both these set. It's not. Is 1 a prime or a composite number? So the answer is it's neither a prime nor a composite number. So 1 is, you can think like a number which is different from all the numbers uh, because it's neither a prime, it's not categorized as a prime or a composite number. It is a factor of all numbers. So now we will see a method to find all the prime numbers below 100. So this is called the sieve of Eratosthenes and it was designed more than 2000 years ago. So let's find out all the prime numbers below 100. So first we cross out the 1 and first prime number we circle it. Now that we have found the first prime number, we will cross out all its multiples. Because 2 is a factor of all these numbers, so those numbers are not prime because all these numbers have, other than the 1 and itself, they have 2 as another factor. So we will cross out all the multiples of 2. Till 100, we'll cross out. So now after 2, we see that 3 is not crossed. So we will circle it. 3 is a prime number because it doesn't have 2 as a factor. So we will now next cross out all the multiples of 3, which are not crossed out before. So like this, we will cross out till. So next number which is remaining is 5. So we will circle it. Now we will cross out all the multiples of 5 which are not crossed out before. So till 95. Next number which is remaining, that is 7. That is also a prime number. So now we will cross out all its multiples which are not crossed out before. So 49, 77 and 91. Now one interesting thing to notice is we don't need to do this crossing out thing again because we have found out all the numbers below, prime numbers below 10. So we see that 100 is 10 into 10. 10 into 10, if we do, then we get 100. So, and also we see that 11 into 11 is 121, which is greater than 100. So now we can understand that any factor of a number which is less than 100, one of the factors has to be less than 10. If you take the number 91, for example, so 91 is 7 into 13. So one of the number is greater than 10, but another one, 7, is less than 10. So like that, 99 also, 9 into 11, 1 is greater, but 1 has to be less than 10. So now that we have covered, we have got all the numbers below 10. So we can safely circle out all the other numbers which are remaining. So we can circle all the remaining numbers to get all the prime numbers below 100. So this is how we get this is a sieve of Eratosthenes to get all the prime numbers below 100. There are 25 prime numbers between 1 and 100, and this sieve was designed, developed by Eratosthenes, a Greek mathematician, some 2200 years back. Isn't it amazing? So now let's do some figure it out from the textbook, Ganita Prakash. First question is, we see that 2 is a prime and also an even number. Is there any other even prime number? Answer is no. All other even numbers have 2 as a factor. So that cannot be, by the definition of prime number, those numbers cannot be a prime number because other than 1 in itself, they have 2 as a factor. Next question is, look at the list of primes till 100. What is the smallest difference between two successive primes? What is the largest difference? So let us paste the sieve of Eratosthenes here. We can see that the smallest difference is between 2 and 3. And the largest difference is in the last 89 and 97. So the smallest difference is 1 and the largest difference is 79 minus 97 minus 89, that is 8. Are there an equal number of prime numbers occurring in the every row in the table on the previous page? Which decades have the least number of primes? Which have the most number of primes? So let us paste the sieve of Eratosthenes again. We see that every row doesn't have equal number of primes. So first two rows have 4, then the third row has two prime numbers. So different rows have different number of primes. So the answer to the first part is no. There are not, every row doesn't have equal number of prime. Decade means each row has a list of 10 numbers, right? So each row can be called as a decade also. So each decades have different number of primes. So which decade has a least number of primes? The last one, 91, and between 91 and 100, we have only one prime number, that is 97. So the last row has the least number of primes. And the first two rows have 4 each. So those are the most number of primes. Which of the following numbers are primes? 23, 51, 37, 26. So we see that 23 and 37 are the only primes. The other two are multiples of some number, 3 and 2. Fifth question is, write 3 pairs of prime numbers less than 20 whose sum is a multiple of 5. So let us list out all the prime numbers less than 20. Now we can see which combination yields a multiple of 5. 2 and 3, similarly 2 and 13, 3 and 7, 7 and 13. There are few more. You can try to find out them. The numbers 13 and 31 are prime numbers. Both the numbers have same digit 1 and 3. Find such pairs of prime numbers up to 100. Let's see the diagram again. We can see that 17 and 71, 37 and 73, and 97 and 79. These are some of the prime numbers having the same digits. Next question is, find 7 consecutive composite numbers between 1 and 100. So we see that there is only one such pair, that is between 89 and 97. So the numbers 90 to 96, they are 7 numbers. They satisfy this condition. Next question is about twin primes. Twin primes are pairs of primes having difference of 2. For example, 3 and 5 are twin primes. So are 17 and 19. Find the other twin primes between 1 and 100. So we see that 3 and 5 already mentioned. After that, 5 and 7 is also 1. Similarly, 11 and 13. This 29 and 31 also we should not, we have to consider this also, because it's actually, if you write it as a single line of all the numbers, then these two are also consecutive. So we may miss out by seeing this C, it may be missed out. So, but we have to consider them also, like 59 and 61. So all these are those twin primes pair. So there are infinitely many twin primes. This is one conjecture which has not been proved yet. So now there are a group of statements. We have to say true or false. Let's examine each sentence. First one, there is no prime number whose units digit is 4. That is correct. True, because any prime number, any number whose units digit is 4 is an even number, and there is only one even prime, that is 2. Second is, B is a product of primes can also be prime. No, this cannot be a prime, because primes have to have only 2 factors, one and itself. And if a number is product of primes, then it has 2 more factors, right? Those 2 primes. So it has 4, at least 4 factors. Next question is, prime numbers do not have any factors. It is also false. It has, every prime number has 2 factors. At least every number has 2 factors, one and itself, except for 1. All even numbers are composite numbers. Is this correct? True. False. This is false. Why? Because 2 is one even number which doesn't satisfies this statement. So all, when we say, we need to consider all even numbers. We cannot leave any even number. The last question is, 2 is a prime and so is the next number 3. For every other prime, the next number is composite. This statement is true because 2 is the only even prime number, or else are all odds. So every odd number has to have a even number after that. So it satisfies us. The 10th question is, which of the following numbers is the product of exactly 3 distinct prime numbers? So let us factorize each of these numbers. 45 is 3 into 3 into 5. 60 is 2 into 2 into 3 into 5. 91 is 7 into 13. 105 is 3 into 5 into 7. And 330 is 2 into 3 into 5 into 11. So which satisfies this condition, that 3 distinct prime numbers? Distinct means unique prime numbers. So 45 has 3 factors, 3 prime numbers, but they are not distinct because 3 is repeating. So the only number which satisfies this is 105. So let's move on to the next question. How many 3-digit prime numbers can you make using each of 2, 4 and 5 ones? You have to use each of the number and you can use only once. What is your guess? How many prime numbers can you make? Actually, we cannot make any prime number because the units digit has to be 2 or 4 or 5. So in any case, it will be either a multiple of 2 or a multiple of 5. So it cannot be a prime number. Observe that 3 is a prime number and 2 into 3 plus 1 is also a prime. Are there other primes for which doubling and adding 1 gives another prime? Find at least 5 such examples. So these are a few examples. You can find more. So that's all for today. Thank you for listening. And you can like, subscribe, and share and comment.